Now that you have learned about specific heat, let's get more into detail about how to calculate it. So let's start with a reminder. What is specific heat? Specific heat is the amount of energy required to raise the temperature of a substance. What that means is if a substance has a higher specific heat, then it is harder to change that substance's temperature, meaning that it will require more energy to get its temperature to change. And on the other hand, if a substance has a lower specific heat, then it's much easier to change that substance's temperature, and it will require a lot less energy. This is really important for life on Earth because of the substance known as water, dihydrogen monoxide, H2O. H2O, water, has a very high specific heat, meaning it's very difficult to change water's temperature. And that's really important here on Earth because water stays liquid on much of the planet because of that high specific heat. It stays liquid. So here is our equation for calculating specific heat. So go ahead and add this to that equation cheat sheet that we have been making all along. Q equals mc delta T. And don't forget on that equation sheet to make sure that you write out what each letter is representing, as well as the units that you should have, because just like we have all semester, your answers will require two parts. You need to have the calculated number, and you need to have the unit. That unit explains what this number means. Okay, so Q is our energy. Energy is still going to be measured in joules. The M, like it always has, is going to represent mass. And for specific heat problems, we need to make sure that our mass is always in grams. So if you are given something besides grams, you need to convert it into grams. And then your answers should always be in grams unless the question specifically asks you to convert it to something else. You should provide grams. C is going to represent the specific heat capacity of our substance being studied, and that is joules per gram degree Celsius. And then delta T is going to be your change in temperature, and that needs to be in degrees Celsius. So this is different than what we've been doing previously, where we always had to have Kelvin. For specific heat problems, we always need degrees Celsius. So if you are given any other type of measurement in temperature, you need to convert it into degrees Celsius first, and then your answer should be in degrees Celsius unless the problem specifically states for you to convert it into something else, okay? So degrees Celsius is where we want to be for these problems. To get your overall change in temperature, you'll need to subtract the final temperature minus the initial temperature. Okay, now that we have our equation, we have our units, let's do an example problem. What is the specific heat of a substance that absorbs 2.5 times 10 to the third joules of heat when a sample of 1.0 times 10 to the fourth grams of the substance increases in temperature from 10 degrees Celsius to 70 degrees Celsius? Okay, so I've gone ahead here and I have analyzed my problem to see what I know and what I need to know. So my first number here, 2.5 times 10 to the third joules, that's joules, so that's energy. So I know that's my Q. And then I have 1.0 times 10 to the fourth grams, so that is my mass, that's my M. And then the temperature increased from 10 to 70 degrees Celsius. So I do my final 70 minus my initial 10 equals 60 degrees Celsius. So there's an overall change of 60 degrees Celsius. Okay, so looking at my equation sheet, I see what I have here. And I see that what I'm missing is the C. So I'm actually calculating the C, which is specific heat. Okay, so just plug my numbers into the equation, the 2.5 times 10 to the third for the Q, 1.0 times 10 to the fourth for the M. My C is my unknown, so I'm going to insert an X, and my change in temperature was 60 degrees. So I'll pop that in there. Okay, so the first thing I'm going to do is I'm going to go ahead and multiply these two numbers together. So 1.0 times 10 to the fourth times 60 is going to equal 600,000. Okay, notice I multiplied grams by degrees Celsius, so I get my unit grams degrees Celsius here with the X. Okay, now to get X by itself, I divide both sides by 600,000. So in my calculator, I'm going to type in 2.5 times 10 to the third divided by 6,000. Be careful doing that. Make sure that you put this information right here, that scientific number, in parentheses to make sure that it does the math correctly for you. And when you do, you'll get 0.0042, and that is my specific heat. So my unit is joules per gram degree Celsius. Okay, double check, are my sig figs correct? Here I have 2 sig figs. Here I have 2 sig figs. Here I have 3. And here I have 3. Since 2 is the least, my answer also needs to have the least. So 0.0042 joules per gram degree Celsius. Okay, if you have no idea how I got this answer, if you are typing in and working this problem along with me and you did not get the same answer, please get into contact with me so I can help you figure out where you got lost and help straighten you back on that path, okay? Because up next is your independent practice.